Okay, so today's lesson is finding volume of a cylinder, sphere, and cone. And you're going to notice on Canvas, or if you're in class, that I gave you a reference sheet. And that is a formula sheet that you're going to be able to use on the test in here when we take the test later, and also on the state test at the end of the year. So you're going to have these formulas. You're not going to have to memorize them. They're going to be given to you, but we need to know how to use them. And so finding the volume of a cylinder, sphere, cone, they're all pretty straightforward. They're not very hard. You just take the formula given and you plug in for pi and radius and height. And so we're going to do that right now. One thing I want to mention is that when we find volume, we're finding the capacity. We're finding how much these shapes can hold because they're three-dimensional shapes. So imagine if we were to open one of these shapes up and pour liquid inside it. We're finding out how much it would hold. And that's what volume is. If you'll notice in the directions on these examples I have, it says find the volume of each shape. Use 3.14 for pi. Now pi, 3.14 is just rounded. It's an estimate that we use. If it tells you to use 3.14 for pi, you need to use that or your answers will not come out correct. If it doesn't tell you to use 3.14 for pi, then you're going to use the pi button on the calculator because it's an exact amount for the pi to use in calculations. So also in the directions it tells me to round to the nearest tenth if necessary. And so some directions may say hundredth, but this one says tenth, so we're going to go one place past the decimal when we round. So I'm going to start with a cylinder on the left. And when I start, the first thing I want to do is write down my formula for volume. And so volume of a cylinder is the area of the base times the height. And if you'll notice, the base of a cylinder is a circle. So what we have is pi r squared, which is the area of a circle on the bottom, times the height. And that's the height of the cylinder, how tall it is. And if you'll notice on the sheet, on volume of a cylinder, it has volume equals pi r squared h. So all we have to do is plug in 3.14 for pi times r squared. R is radius of the circle. So on the bottom, the radius goes halfway across, so that's 5 squared, times the height of the cylinder, which is 8. And this cylinder is laying on its side, but if you stood it up and set it up on its base, it would be 8 centimeters tall. So if I take my calculator and just punch all that in the calculator, 3.14 times 5 squared times 8. And I can do that all at one time. I get 628. So there's no need to round that one. It came out exact. I do need to label volume with, this is centimeters, and volume is always going to be cubed. So that would be centimeters cubed. Not the number that gets cubed, but the units get cubed, whatever they happen to be. In this case, this examples, I've used centimeters. So it's 628 centimeters cubed, and that's just how simple that is. I will tell you this, you need to be able to recognize the shape cylinder, sphere, and cone because it may not always tell you what the shape is, and you have to know. A cylinder is going to be, I always tell my classes to think about a soup can because it looks like a can. So a cylinder would be in the shape of a can. The next shape is a sphere. A sphere is like a ball, like a basketball or any kind of baseball, anything. The formula for sphere, if you look on your sheet, is volume equals V equals 4/3 pi r cubed. So the only thing we have to have for this one is pi and radius. So we're just going to take that formula. We're going to put 4/3 times pi, which is 3.14 in this specific example. And then r cubed. R is radius. Radius, remember, goes halfway across the circle. So that is 7 cubed. I'm going to punch all that in my calculator. Remember, we can do fractions in the calculator as well as exponents. So I'm going to do 4/3 times 3.14 times 7 to the third power. Now I get that comes out of the long decimal, so I'm going to round that. It's 1,436.0266 repeating, so I'm going to round that to 0.0. And you may say, well, do I have to put the 0.0 in that case? You do have to put it. If it says round to the nearest tenth and it rounds to 0.0, you still have to put that. So, and that's going to be centimeters cubed, just like on the last one. All volume is cubed, all volume. So that's volume of a sphere. The next shape is a cone. And a cone, if we write down our volume, and it looks like an ice cream cone. If we write down the formula, it's 1/3 pi r squared h. One thing you're going to notice is that the formula for a cone is just like the formula for a cylinder, except it has 1/3 in front of it. And that's because a cone is 1/3 of a cylinder. So basically, if you took and filled up, if you had a cylinder and a cone that had the same radius and height, these don't, but if you had two that did, it would take 3 of those cones to fill up a cylinder. So a cone is 1/3 of the size. It would take 3 of them to fill up a cylinder with the same radius and height. Okay, so I'm going to use this formula. Volume equals 1/3 times 3.14 times radius squared, so that's 4 squared, times the height, which is 13. And I'm just going to punch all that in my calculator. So I'm going to do 1/3 times 3.14 times 4 squared times 13. And when I do that, I get another long decimal. And this one rounds, it would be 217. Mine says 0.706 repeating. So I would just round that to 217.7. And I do need to also put centimeters cubed on this one as well, because again, all volume is cubed, no matter what the shape you're finding it of. And so that's how you do volume of a cylinder, sphere, and cone. And again, that's pretty straightforward. There's not much to it other than just taking your formulas, and they're going to be given to you, and plugging in what you have given to you, and then rounding your answers. So it's all pretty simple. If you have any questions, let me know. I'm going to let you work on your worksheet now and see how you do practicing with it, and then we'll look at some more examples tomorrow.